Hello friends, welcome back to Prosto Hub. Myself Dr. Jolsna and coming to the second session of our current topic, precision attachments. So in our previous session, we have gone through the definition, components, advantages, disadvantages, indications, contraindications, the important classification, and also the selection criteria of precision attachments, the clinical application of precision attachments in removable, fixed as well as over dangers, and their mechanism of action. In this section, we will be discussing some of the precision attachment design and also about the abutment tooth selection and its preparation. So before getting into the session, I request everyone to please do like and share my videos. And if you're new to this channel Prosto Hub, please do subscribe and support me. If you have any queries or feedbacks, you can either comment below this video or you can mail me at this mail ID. So let's start. Attachments that we are going to discuss today are the intracoronal attachments, which are mainly the Chairs attachment, McCullum, Chrisman, and Shapesman. The extracoronal ones, there is a Roche attachment, Dalbo, and Zika. The over-danger attachment classified into stud attachments and bar attachments. The first intracoronal precision attachment, which was introduced by Dr. Hermann E.S. Chase in 1906. So, the first intracoronal attachment was T-shaped with the female component attached to the abutment tooth. So we have discussed about the intracoronal attachment in our previous session. We know that they are incorporated entirely within the contours of the crown. We have also discussed the advantages and disadvantages. So the first intracoronal attachment was T-shaped, which was later modified into an H-shaped design. So here you can see this is the T-shaped male component and this is the female component and this is modified H-shaped. So the main principle was the mechanical friction which provided the primary retentive factor, and the contact with the walls of the receptacle provided the lateral stability to the prosthesis. And the H-shaped male component had more contact area and it was more advantageous. Is the Chrisman attachment. So basically, intracoronal attachments can be classified based on their adjustment potential. So there are friction fit intracoronal attachment with adjustment potential and those without adjustment potential. The Chrisman, McCullum attachments, etc., comes under the friction fit attachments with adjustment potential, and tendon motors is a non-adjustable friction fit attachment. So Chrisman attachment is similar to tendon motors connector, which we have already discussed in stress breakers in FPD, and the Chrisman attachment is around 7 mm tall. It can be reduced by 2 mm based on the available space. So here the male component has got a vertical groove on the proximal surface which can be widened to increase the tightness of the attachment. So this is the groove that is present on the male component, and this is available in two forms, the rigid and the resilient ones, and the retention is mainly by the frictional grip and also mechanical retention by a spring clip screw that is accommodated in the male component. The McCullum attachment, which is an H-shaped attachment similar to that of the Chrisman attachment with a vertical groove on the buccal side. So you can see a vertical groove that is present on the buccal side of the male component. And this is available in two sizes, the small and the bigger one. And the male component is tapered at the gingival aspect to facilitate ease of insertion into the female. And the attachment offers excellent buccolingual stability, and the retention is adjustable by expanding the adjustment slot that is present in the face of the female. The last one in intracoronal attachment is the Shapesman, which is again an H-shaped one, and it has got both frictional retention and mechanical retention. And the mechanical retention occurs through a spring-loaded plunger that is attached in the male unit, and this spring can be replaced every 6 months to prevent wear, and this can be easily replaced chairside. The extracoronal attachments. So here we know that the attachments are placed outside the contours of the abutment crown, and also the main portion of the attachment is attached to the abutment. We have classified extracoronal attachment into three types, that is rigid, resilient and bar type. So one of the oldest attachment in extracoronal one is the roach attachment. Here the male component or the matrix is a round ball that is attached to the abutment and the matrix is a tube. And this is also called as ball and tube attachment. And similar to this is the pin and tube attachment, where there is a pin in the abutment, that is the male component, and the matrix consists of a tube, or the female component consists of a tube which fits into this pin. Tablex attachment, which is again a rigid extracoronal attachment. So this has got a very long projection unit with slots for two pins, and the main disadvantage is the increased length, and also plug control is difficult since it is bulky, and it is usually used or preferred for long edentulous spans. The Dalbo or Della Bona attachment, which is one of the oldest, most successful and popular attachment, as it features lateral stability, vertical resiliency, and also hinge movement. Here, the male component is L-shaped with a terminal ball joint. So this is the male component, and the female component has got a socket to receive this ball. Now, there are finger springs around the socket which modifies the retention. So the vertical resiliency is rendered through the presence of these springs. Now this attachment is available in two sizes, long and short. Long ones are used in class 2 RPDs, short ones are used for class 1 RPDs. Is the Zika attachment, which is a very popular extracoronal attachment that is used in all conditions. So here the male retentive pin is attached to the denture and the female ring is attached to the abutment teeth. So you can see that. So this is the female ring and the male retentive pin. And the retentive pins are partially split into 4 segments, and the biggest advantage is that retention can be improved by widening these partially split segments. Now there are different types of retentive pins available based on their dimensions, and here guiding planes are required to improve the stability. So this is about Zika attachment. Coming to the overdenture attachments, so here the attachments are placed on the residual roots, and they are classified as stud attachments, bar attachments, and then also auxiliary attachment. One among the stud attachment is the O-ring attachment, which consists of a stud, an O-ring gasket, and also a metal housing. So the stud portion is the male component, and which is attached to the abutment tooth, and the O-ring gasket along with metal housing is incorporated into the denture. Now, when the denture is inserted into place, the O-ring gasket stretches over the stud and it is seated in the undercut that is present below the stud. So you can see an undercut that is below the stud. So when the denture is being inserted, this O-ring gasket fits into this undercut. And these gaskets are available in a different range of hardness based on their retention requirement. And the main disadvantage in this system is that a lot of interart space is required for the stud, and also an additional 2 mm is needed above the housing in order to avoid perforation through the denture base. And these O-rings are made up of silicon, nitrile, fluorocarbons, etc. The Rotherman eccentric attachment, which is a button-shaped attachment. So this is the smallest of all available overdenture attachments, and the attachment looks like a press button with a groove. And here you can see the male component is an eccentric cylinder with undercut or groove. So this is the male component, and the female component is a clip or the clasp arm. And this is activated by bending the clasp arm towards the center. And here the attachment can be placed in a space as less as 2 mm. Even the height of the attachment is also less, that is around 1.7 mm for the resilient system and 1.1 mm for the rigid system. First one in stud attachment is the zest anchor. So here the male component is a nylon stud which is attached to the denture base. Female component is attached to the root canal, and it is available in two different sizes based on the root length and diameter.
The main advantages of zest anchor is that it reduces vertical space requirement. So most of the bulk goes inside the canal. So less space is required and the loads are transferred more apically. So here first we prepare the tooth up to the gingival level and then we prepare the canal and then the canal insert can be directly cemented onto the root and then the male component, that's a nylon stud, is attached with self-cure resin. The bar attachments. So bar attachments are much more preferred than stud attachment because they offer better resistance and also splinting of abutment teeth. And also the maintenance as well as follow-up of a bar attached prosthesis is much less when compared to a stud attachment prosthesis. So here we discuss a Dolder bar, which is basically a bar with an egg-shaped cross-section that connects the abutment teeth together. So here a clip which attaches to this bar that is incorporated inside the denture is the female component. So the denture with the clip attaches to the bar by tensor friction and provides a retention. Now here first the abutment teeth should be root canal treated and the crowns removed to the gingival level, and then these Dolder bars are soldered to the screw attachment system that is placed inside the roots, and the U-shaped channel or the sleeve that is incorporated into the denture clips onto the bar when it is seated inside the mouth. And Dolder bar is usually used to link the root faces of two lower canines and they are made up of hard inlay gold. And it can be used with or without a spacer. The bar is rigid if it is used without a spacer and it is resilient if the spacer is used. So spacer actually controls the degree of movement. This is the movement seen in the Dolder bar. So Dolder bar allows vertical translation as well as slight sagittal rotation. Now the disadvantages of Dolder bar is that it is bulky and it is difficult to control plaque. Coming to the Ackerman bar, which allows free movement of the prosthesis. So this is available in different cross sections. The circular cross section can be bent in all planes, whereas pure and oval shaped ones are rigid. And it's applied for overdentures as well as implant prosthesis. And the principal feature of this Ackerman bar is that it can be adjusted to follow the vertical contours of the mucosa and also the anterior posterior curvature of the edentulous ridge. And here also the spacer provides for both vertical as well as rotational free movement of the prosthesis. Coming to the Hader bar system, which is most widely used one. So Hader bar can be used as a retainer for tooth as well as implant supported prosthesis. This is available in prefabricated plastic patterns that can be adapted onto the master cast and then cast in the alloy of choice. Now it is the sleeve of this Hader bar system which makes it different from other systems. So here the sleeve is also made in plastic, whereas in other case it is made up of metal. So here the plastic sleeve can be easily replaced on chairside when their retention reduces. And also there is no spacer in Hader bar system. Let us discuss the selection and preparation of an abutment tooth. So the abutment teeth have to be evaluated for their pulpal status, that is vitality of the pulp as well as size of the pulp chamber should be assessed. The periodontal condition should be assessed and also occlusogingival length. So we know that a minimum of 4 millimeter of clinical crown is necessary in order to retain an attachment. Preliminary diagnostic preparation of abutment teeth. So this is to determine the location and position of the attachment on the abutment. So first the diagnostic cast is surveyed using a surveyor. The tilt of the cast is determined in order to know the most favorable path of insertion and removal of the RPD, and also buccolingual position of the attachment should be established. The preparation of the diagnostic cast. So once the proper tilt of the cast is determined, we have to prepare the diagnostic cast using handpiece that is attached to the vertical spindle of the surveyor. Now parallel box-like recesses are prepared on the abutment teeth using pencil marks as guide. And one more thing to note is that the path of insertion and removal of precision attachment should not be same as with that of the abutment retainers. This reduces the risk of an abutment retainer getting dislodged from the abutment after final cementation. We have to fabricate an intracoronal template in order to transfer the location of the box recess to the abutment teeth. So for this, the templates can be made of cast gold or metal or auto-polymerizing acrylic resin. So the prepared abutment teeth is lubricated and either wax or resin is adapted in order to make the coping, and the wax is cast. And once the template is finished, it is transferred to the mouth, placed over the teeth as a guide in preparation, and thus it reproduces all the details of the box-right recess that we developed on the diagnostic cast. Is the abutment tooth preparation. As we have said, we have made an intracoronal template, and using this preformed template, we can prepare the box recesses on the abutment teeth. And the box recesses can also be prepared freehand. Next is the depth monitoring. So monitoring of the depth is important to prevent the pulpal damage. And then the impression is made. The provisional restoration to abutment teeth can be fabricated, and also a transitional removable processes can be given. Finally, coming to the placement of attachments. So once the master cast is fabricated, it is placed on the surveying table at the tilt that is established during the diagnostic abutment preparation. And a wax trimmer is used to carve parallel surfaces in case we need guiding planes. And there are two methods of relating the intracoronal attachment. One is the direct method, where the attachment is placed within the confines of the wax pattern of the abutment tooth and luted with sticky wax using an attachment mandrel that is attached to the surveyor. And then there is the indirect method, where the female attachment is luted with sticky wax after the casting is made, and then it is invested for soldering. So one of the advantage of this indirect technique is that as the abutment have already been cast before the attachment are soldered, alignment problems will be minimized. Now we have to attach the male component. So we design the RPD framework and then cast it, and then the male attachment has to be connected to the minor connector. So the male attachment is soldered to the minor connector using the spot welding method. So this is the preparation of the abutment tooth for the attachment of the intracoronal attachment type. To the success criteria for precision attachments. So we need correct treatment planning and case selection, a well-motivated patient with good oral and physical health, a good level of knowledge of attachments, and a teamwork between clinician and technician, and also regular adjustment of the attachment. So proper maintenance and follow-up is a must. So concluding this session, the use of precision attachments requires a thorough knowledge of basic prosthodontic principles and appropriate training and experience with a particular attachment that is used, and technical skills and clinical ability. But the precision attachment usually is surrounded by an aura of mystery, implying that greater skill is required in their use, and this act as a contributing factor in discouraging their general use. But from a patient's viewpoint, precision attachment offers more comfort, security, and also aesthetics. We have already discussed in the introduction that precision attachment provides a balance between functional stability and cosmetic appeal. Unfortunately, most often we select precision attachment from descriptions in commercial catalogs. But a thorough understanding of the biomechanics, different attachment types, and also knowledge of material science is essential in treating a case of precision attachment. Then, the precision attachment serves the function of retention, stress distribution, and aesthetics successfully, providing that the case is planned based on sound biological and technical grounds, and also proper care is rendered by the dentist and the patient during the maintenance phase. Then the precision attachment becomes what it should be. That's a beautiful example of bioengineering that will be compatible with the continuing health of masticatory apparatus. These are my references for this session. So I thank everyone who have watched this session, and if you really liked this video, please do hit the like button, and also please do like, share, and also subscribe Prosto Hub if you are new to this channel, and please stay tuned for more prosthodontic videos If you have any queries or feedbacks, you can either comment below this video or you can mail me at this mail ID. So it's a bye from Processor Hub until our next topic.